Steam engineers spent decades mastering their craft. Then railroads introduced diesel locomotives. The veterans were furious. They had been replaced by push-button machines. They sabotaged the diesels. They made them fail, and almost proved diesel was a terrible mistake. In the years after World War II, the railroad yards changed overnight. Steam engines, once kings of the rails, sat cold and silent while shiny new diesels lined up for their first runs. For the men who had spent decades mastering the old giants, it was more than a change in machinery. It was a gut punch. These engineers had learned to read fire by color, to feel a problem by the tremor in a lever, to listen for trouble in the rhythm of pistons and steam. Every run was a test of skill and nerve. Now management promised a future where anyone could run a train with a push of a button. The message was clear. A corporate memo, circulated in 1946, declared the coming of the push-button era. No more need for firemen. No more need for the man who could coax a bulky boiler back to life on a freezing night. Diesels would run farther, faster, with fewer hands and less fuss. The Pennsylvania Railroad's T1 duplex, a marvel of modern steam, had barely settled onto the rails before the order came down: cancel the program, scrap the upgrades, and send the engines to storage. By 1958, every one of the 52 T1s had been cut up for scrap. Years of innovation and pride, gone in a few strokes of a pen. For the veterans, it was a public shaming. The skills they had spent a lifetime perfecting were now dismissed as obsolete. Shop floors echoed with rumors. Management said anyone could be trained to run a diesel in a week. The men who had once been craftsmen, trusted to bring a train safely over a mountain pass in a blizzard, were now told their instincts didn't matter. The new machines didn't need them. Some tried to adapt. Most felt the sting of betrayal. The pride of a generation was swept aside by a wave of efficiency and cost-cutting. The old ways were declared dead, not because they had failed, but because someone in an office decided the numbers looked better on a balance sheet. In that moment, the foundation was laid for a silent rebellion. The men who had kept America's trains running through war and depression now found themselves on the outside, watching as their world was dismantled piece by piece. The sense of loss ran deep, and for many, it would not be forgiven. The quiet rebellion didn't start with sabotage. It began with silence. In the cab of a brand new diesel, a rookie asked how to start the engine on a cold morning. The veteran at his side shrugged, gave a half answer, and let the kid fumble with the unfamiliar controls. There were no flames to tend, no firebox to coax, just a row of switches and a cold steel lever. But the old hands found ways to make the new machines stumble. In the locker rooms and lunch shacks, stories spread of rookies left to figure out complicated startup routines on their own. One engineer recalled years later being told to just crank it and see what happens. If the diesel coughed and stalled, the blame landed on the new guy. Sometimes the veterans would forget to mention the importance of checking oil levels before a long haul. Other times they watched as a rookie skipped a pre-trip inspection, only to discover a seized engine miles down the line. Misinstruction became a rite of passage. Some old-timers taught the wrong procedures on purpose, showing how to throttle up too quickly, or how to skip the priming step that kept fuel flowing on grades. A few whispered that the best way to learn was by making mistakes. But the pattern was clear. The more the new men failed, the more management doubted the wisdom of dieselization. Hazing went beyond words. On the night shift, a veteran might leave a switch misaligned or a valve half open, knowing it would trip a warning light after departure. In the yards, a rookie was sent out with a nearly empty fuel tank. When the engine sputtered to a stop halfway up a grade, the story became a lesson that these new machines can't handle real work. Union oral histories recall episodes where knowledge was hoarded like treasure. One account from the Brotherhood of Locomotive Engineers describes a senior engineer who watched in silence as his trainee struggled with a lube chart, offering only a smirk. Rookies faced a wall of resistance, not just from the machines, but from the men who ran them. The sabotage, when it came, was subtle. A handful of sand in a fuel tank, the wrong lubricant swapped in the shop, an electrical connector left just loose enough to fail in the rain. No one admitted to these acts outright, but the stories piled up in the break rooms and on the night trains. Each failure was chalked up to the supposed fragility of diesels. Each breakdown was a quiet victory for those who wanted to prove the old ways were better. By the early 1950s, the pattern of passive resistance had become impossible to ignore. New hires struggled to learn from men who no longer wanted to teach. Engines failed for reasons that were hard to explain. Management blamed the unions. The unions blamed the machines. But beneath it all was a simple truth. The old guard was not going to give up their pride or their power without a fight. Sabotage wore 1,000 faces and left almost no fingerprints. In the dark corners of the yard, a handful of sand found its way into a fuel tank. Not enough to be obvious, just enough to grind a pump to a halt somewhere out on the line. The rookie blamed the machinery. The veteran kept his mouth shut. The wrong oil in the crankcase could turn a long haul into a rescue call. Diesel engines, new to the rails, needed precise grades and careful checks. But the old hands, who once mixed water and fire by feel, watched as the new men reached for the wrong can. Sometimes they let it happen. Sometimes they gave a nudge in the wrong direction. A seized bearing on a mountain grade became another story for the break room. These new engines just can't take it. Electrical gremlins were the craftiest trick of all. A connector left just loose enough to fail under a hard rain. A wire nudged out of place, waiting for vibration to shake it free. Most days, the fault was written up as bad luck. But the pattern grew. Reports of shorted circuits and sudden power loss stacked up in maintenance logs, always just shy of proof, always just one more strike against the diesels. Controls were another battlefield. A throttle misadjusted, a linkage set off by a fraction, enough to cause erratic running, surges, and stalls. The rookie at the controls looked like a fool. The old-timer beside him shrugged and said, "Must be these newfangled machines." Every act was small, deniable, and wrapped in the fog of inexperience. No one confessed. No one needed to. Oral histories from the Brotherhood of Locomotive Engineers recall these tactics. Sand in the tank, the wrong oil, a loose wire, a misset lever. Each story told in a low voice, never quite admitting guilt, always blaming the machine. The sabotage was never about destruction. It was about proving a point. Every breakdown, every stranded train, every unexplained failure was ammunition. The men who had been told their skills were worthless now had the evidence they needed. The new engines failed, and failed often. The more they failed, the more management wondered if the old ways had been abandoned too soon. 4 main tactics surfaced again and again in the stories: contaminating fuel, sabotaging lubrication, tampering with electrics, and misadjusting controls. Each one left a trail of breakdowns that looked like bad luck, but added up mile after mile to a pattern. With every silent act, the stakes grew higher. What started as quiet resistance was about to spill out onto the main line, where the real cost of sabotage would be paid in public breakdowns and mounting doubt. Trains stalled on main lines. Dispatchers scrambled to reroute traffic, but the new diesels sat dead in the worst places, blocking busy yards, stranded halfway up mountain passes, or stuck in tunnels with their lights flickering out. The failures weren't just inconvenient, they were dangerous. In the spring of 1949, a diesel-powered medical train bound for Denver ground to a halt on Raton Pass. The official report blamed a lubrication failure. Word spread that the engine had been serviced by a crew who'd spent their whole careers on steam. The delay made the morning papers. Headlines questioned whether the railroads had gambled too much on unproven technology. Patterns like this kept repeating. Over 24 incidents in Pennsylvania railroad logs from 1948 and 1949 described engines failing with foreign matter in the fuel. Crews reported a fine grit clogging injectors, pumps choking, and engines dying in the middle of nowhere. The mechanics wrote it up as bad luck or poor fuel quality, but the clustering was hard to ignore. On the Union Pacific, a freight train carrying perishable goods seized up on a steep grade outside Cheyenne. The rookie at the controls said he had checked the oil, but the wrong grade had been used. Bearings overheated, the engine locked solid, and the entire train had to be rescued by a steam locomotive sent from the next division. These breakdowns were more than mechanical problems. They became public spectacles. Reporters flocked to scenes where diesels had failed, snapping photos of stranded passengers and frustrated crews. Railway Age ran stories about mysterious stoppages, and rumors of sabotage began to circulate in the trade press. Passengers complained about late arrivals, missed connections, and cold cars when the heaters cut out. Freight shippers threatened to pull contracts, blaming spoiled goods and lost time on the new engines. Inside the dispatch centers, the tension was constant. Operators watched as green lights on the board turned red, one after another. A single failed diesel could back up traffic for hours, forcing dispatchers to juggle schedules, detour trains, and scramble for spare engines. When a diesel died on a mountain pass, it wasn't just an inconvenience, it was a crisis. Crews were left exposed to the weather, sometimes for hours, waiting for help that might never come. The old-timers in the break room called it poetic justice. The new machines, they said, couldn't handle the work. For railroad executives, the embarrassment cut deep. Boardroom minutes from 1947 reveal heated debates over whether dieselization was a mistake. Some directors argued for halting new purchases until reliability improved. Maintenance costs soared as engines were towed back to shops, torn down and rebuilt, often for the same problems, over and over. The clustered failures looked less like bad luck and more like a warning. Maybe the old guard had been right. Maybe the railroads had moved too fast, betting the future on machines that weren't ready for the realities of American railroading. Yet for every breakdown, the evidence was both damning and elusive. No one could prove sabotage. But the pattern was clear. The more the new diesels failed, the more management doubted the wisdom of abandoning steam. The men who had been told their skills were obsolete now had something to point to: stranded trains, angry customers, and headlines that questioned the whole project. The failures became their proof, and for a moment, it looked like the old ways might win after all. Inside the boardrooms, the mood soured as breakdown reports piled up. Meeting minutes from 1947 show directors arguing over whether to halt new diesel orders. One executive called for a pause, pointing to a 30% spike in downtime and maintenance costs that refused to budge. Another demanded answers for why so many brand new locomotives were towed back to the shop, torn down and rebuilt for the same problems, again and again. The numbers looked damning. Early diesels were supposed to run 100,000 miles between major repairs. Instead, some units barely made it 20,000 before choking on grit or seizing up on a grade. Internal memos circled with phrases like premature adoption and unproven technology. But in the middle of the doubt, a new idea took hold. What if these failures weren't just setbacks, but data? A wry voice in the room reframed the disaster. Every breakdown, every public embarrassment was a field test, proof of what the new machines could and couldn't survive. Instead of pausing the diesel push, executives ordered the failures cataloged and sent back to the manufacturers. The crisis became an opportunity. The railroad's misfortune would be the diesel's education. One engineer at EMD sat behind his desk, staring at a stack of failure reports from the field. Fuel pumps clogged with grit, bearings seized on mountain grades, electrical panels shorted out after the first hard rain. It wasn't sabotage that filled his mind, it was survival. If the diesels couldn't be made reliable, the whole diesel dream would collapse. So the manufacturers went to work. In 1949, EMD issued a bulletin. Every locomotive would get triple-stage fuel filtration and baffled sumps to trap the dirt before it reached the injectors. Drawings went out for sealed electrical cabinets, keeping rain and dust away from the wiring that had been so easy to sabotage, or just unlucky. Baldwin and Alco followed, rolling out improvements of their own. Sumps were enlarged, pumps upgraded, and new specs for lubricants hammered out. Mechanics in the shops replaced old parts with the new designs as fast as they arrived. The changes worked. By 1951, the average diesel ran 150,000 miles between major failures, triple the distance of the worst years. The breakdowns slowed. The headlines faded. What began as a crisis became a turning point. The same failures that nearly killed dieselization had forced the machines to grow up fast, turning fragile prototypes into the workhorses that would end the steam era for good. Today, every new technology faces its own quiet resistance, sometimes from the hands that know it best. The old steam men tried to bury diesels with sand in the tanks and wrong oil in the lines, but their sabotage exposed every flaw engineers had missed. Progress isn't always embraced. Sometimes it's stress-tested by those it betrays. Sometimes the best way to kill technology is to try very hard to break it.